My name's Alan Beresford. I'm Managing Director of Eco Cooling Limited, and in the next half hour or so I'm going to give you a presentation about evaporative cooling of data centres and server rooms. And to explain it best, I thought it would be appropriate to do a case study to see what it's really like there out in the field. The company I'm going to talk about is a company called M247 up in Manchester. The reason I'm going to talk about M247 is it's a very professional, well-organised, traditional data centre with conventional equipment. And they were looking for a retrofit solution with nothing too complicated or too bespoke. They've got their 500 kilowatts of load, a conventional raised access platform floor, conventional cracks, conventional racks. And they're running at a very good level of efficiency for that type of data center. What we call a PUE, a power utilization effectiveness. Now, what do we mean by PUE? Very, very important concept. We look at an efficiency of a data center and its energy use, or a server room, by looking at the total the ratio between the total energy used against what's really useful work done in the IT equipment. Now, many data centers in Britain run at a PUE of anything up to 2.5. Now, the only way you can get to using more energy in your ancillary equipment than in your IT equipment is really by putting it into the cooling equipment. Many people are absorbing as much energy in their cooling as they are in their IT. Now, this is obviously an incredible cost, both in terms of the electricity usage and its carbon footprint, and also the consumption of the available power, where many sites have run out of available power. So, we look at this ratio called a PUE. You'll also come across another expression called a DCIE, a data center infrastructure efficiency, which is purely the inverse of it. It's like a percentage efficiency. So if you look at your 100 kilowatt data center, typical thing, you'll have 100 kilowatt going into your IT load, maybe 100 kilowatts going into your cooling system, and 8 kilowatts into things like UPS losses and distribution losses and transformers. Good data center, like M247. Running at about 1.6, but still probably 50% equivalent of their IT load going into their cooling system, using good quality cracks. Now, what I mean by a crack is a computer room air conditioner, your Airedale, Denko, that type of piece of equipment. Using good quality equipment with all of the extras to maximize the efficiency. However, that's still quite a cost load and quite a significant carbon impact. So what can we do to improve things? If we use a ventilation system and use evaporative cooling instead of refrigeration, then it is technically possible to achieve a PUE of 1.1. That's an incredible level of saving, and in some cases, it looks too good to be true. But what I'll try and explain over the next few minutes is how we really achieve that using simple engineering and in a simple modular system designed specifically for the IT sector. At the end of the presentation there'll be an opportunity for questions, so please, if you could wait till then, it would make things a little bit easier for us in terms of presentation and timing. How does it work? Well, it's no more complicated than air and water and their relationship. In the UK, when it is hot, the air is also low in relative humidity. And air is like a sponge. It loves to soak up water. If we put this air in contact with a wetted filter pad, water will evaporate into the air stream. The heat required to change the water from a liquid to a gas comes from the air, which then cools down. And we incorporate these wetted filter pads into a thing called an evaporative cooler, which is four wetted filter pads with a water circulation system and a fan to move the air around. And we build this into a device called a CREC, a computer room evaporative cooler. Straight away, let's get to the numbers. Let's look at what we were trying to achieve at the planning stage with M247. As I said earlier, M247 is a 500 kilowatt, half megawatt data center. So on the lower third in terms of the size of data centers you would come across. When we look at a data center, a lot of people do get a little bit misled in that they do concentrate a little bit too much on the actual cooling load. There's a little bit more to it to that. What we're actually trying to do is give all the servers the right volume of air. Wherever that air comes from is irrelevant, but you've got to give it the right volume. Now, 500 kilowatts of servers actually adds up to about 42 cubic meters per second of air. That's a lot of air. Where does it come from? The next stage of that spreadsheet, you will see there's a comparative cost, 2 columns between refrigeration and an eco-cooling CREC system. The coefficient of performance of refrigeration in a PUE 1.6 data center will be about 2. That means for the 500 kilowatts of IT load, we will be putting 250 kilowatts of energy continuously into the cooling system. The equivalent capacity of cooling delivered by an eco-cooling CREC system would only require 21 kilowatts of electricity. So you'd see 92% less energy put into that system. A very considerable difference. Now down to the finances of this. 8,760 hours in a year. We can't get away from 24/7, 52 weeks. A lot of hours. So the M247 project, if they'd have gone down the existing conventional CREC route, would have been using over 2 million kilowatt hours of electricity per year. The eco-cooling system would require less than 200,000. And at 6.5 pence a kilowatt hour, their annual running costs for the CREC system would be 140,000 compared to just over 10,000 for an eco-cooling system, with a potential environmental benefit of saving over 1,000 tons of carbon as well. Big numbers. However, there are a few things that we mustn't lose sight of when we start doing a project like this. We mustn't lose sight of the real objectives.